Okay, this time I wanted to talk about how transformers work, but how they actually do what they do. I've got 3 transformers out of microwave ovens. There's that one I've been using for my DC power and that 12-volt DC motor. And I have another one here that I use to show experiments on how the transformer will magnetize steel. I have a third one which I use to show the power and difference in the secondary coil windings, which basically turns into a welder. And you've probably seen that on YouTube. My little setups here are primitive, but they work. I don't need anything extravagant. But I'm going to break it down into little pieces here and show you how it works, how a transformer actually works. But the first thing I want to do is show you why this one's turned sideways, like that, instead of, like that. It's sideways in here, but I've got it here so I can reach my switch. But I'm going to explain to you how the transformer actually works to get the juice going around the primary coil up and down, north and south, into the secondary coil, and the power that it has open like this, as opposed to putting the caps on them. They have to have the caps on them to get full potential. I'm going to explain that on this segment. But first, I'll show you some of the how they run, or how this one works to get the juice to go from the primary to secondary, and what it's doing, where it's going. I'll show you that first. And this video here will show that this just laminated plates of steel. You can't use a solid block of steel to make a transformer work. It has to have these laminated, these little plates that have like a glue between them, holding them together. And that gives a space between each one of these plates. Like I said, it won't work with a solid block of steel. Now you set your primary coil into your transformer core, and then you set your secondary on top. These two aren't actually touching, and the wires in the primary go to your wall, and the wires in the secondary do not touch the primary. What I want to show you on this transformer is, this is just a regular screwdriver. And it's just iron. It's not picking up these little pieces of steel here. They're just little pieces of iron rods. So the screwdriver is not magnetized. But if I lay the screwdriver long ways in this transformer, like that, and then energize it for a few seconds, it magnetizes the screwdriver. It'll pick up the little pieces of steel. Picked up that little piece of steel and a little bigger one. Then what I want to show is, if I put the transformer crossways across the W of the transformer, instead of long ways like I had it, I'll put it this way and energize it for a few seconds, and it demagnetizes it. And I'm going to show you one more thing. I'm going to magnetize it again. So it's magnetized now. It's hanging onto the steel. And if I just go to one of the sides of the W and energize it, it demagnetizes it again. And one last thing is, if I put the screwdriver across the transformer this way, energize it, I'm going to try and pull the screwdriver off. And you're going to notice that it holds the screwdriver to the transformer with a lot of power. I just about can't pull it off there. But if I put the cap on the transformer and then try that, it doesn't magnetize. That's because with the cap off, the north and south are shooting out, shooting down, shooting out, pulling in from the air, pushing away from the transformer core. Pulling in, shooting out the middle, pulling in from the air, pulling down the middle. But when you put the cap on, it causes it to recycle it from both sides. So that gives you, when you put the cap on the transformer, you get 4 times the power out of this secondary coil that you do without the cap. I found that out, but like I said, I've blown up my meters trying to figure out how much difference there is from the cap on and the cap off on power. But I'm going to go to a little animation now that shows you what's going on with the cap on and cap off on the transformer that makes the secondary coil get maximized by the power this can put out with the cap on it. So with the cap off of the transformer, the magnetic field, or the energy, or the accelerated gravity, is just shooting mainly up and down the center of the core, up into the air, and then pulls it in out of the air. So the sides aren't near as powerful as the center with the cap off. However, when you put the cap on, it tends to make it cycle pushes it around and back into itself. And then when it goes the other cycle, the AC current goes the other way around the transformer. So it's back and forth. Remember, both of these with the cap on or cap off, it's doing this 60 times a second, 60 cycles a second, or 60 hertz. That's the frequency of it. That's how frequently it goes back and forth. So that's what that means. But that's why when you put the cap on, you have about 4 times the power.